In this video, we'll learn how to do visual analysis on a categorical column. Categorical columns are basically qualitative columns. For example, places, names, departments, etc. are typical examples of categorical columns. Unique values in the categorical columns can be called as levels or categories. Like if you have a country column, the individual countries are example of categories or levels. When we take one categorical column at a time, one can look at the frequency of each categories or level. For example, if you have a product name column, we can count the frequency of each product. This analysis will help us to identify the following. First, we can just identify the most common categories in a column. Second, we can also understand the distribution of the categories. And third, we can separate the vital few from trivial many using Pareto analysis. To read more about this particular Pareto analysis, I would refer to the article that is linked in the bottom. Let us understand this using an interesting example. This is a sample data for HR attrition and performance analysis. This data set contains information about many employees like their department, their age, education background, education field, gender, and their hourly rate and their job involvement, job satisfaction, marital status, etc. We can see that we have multiple categorical and numerical column in this particular data, and this one has a very useful column called attrition and tells whether the employee is currently staying in the company or not. This data set can be used for multiple purposes like EDA, and you can also try predicting what makes an employee to leave an organization. So, you can do some attrition analysis as well. This data set is available under IBM Watson Analytics resources. In this data set, we have many categorical columns, as I mentioned: job role, department, education field, etc. We will choose education field and try to understand how to do frequency analysis on this categorical column. First, let's identify how many unique categories we have in this column using R. You can download this file from my GitHub repository, github.com/skadirmani/datasets. After reading this CSV file, we can just check out the number of rows using dim function. So, we have 1470 rows, which is close to 1500, and we have 35 columns. And we can look at the structure of the data as well, like what is the individual data types of each column. So, you can see we have a lot of integer factor columns. So, basically numerical and factor columns we have. After this, we can specifically call unique function and pass the education field column alone. To select a particular column, we will be using $symbol. When we execute this, so we can see that there are categories like life sciences, medical, marketing, technical, human resources, etc. If you want to know how many unique categories we have, you can wrap this on top of length function. So, totally we have 6 unique categories. Let us now look at what is the frequency of each of these category using table function. To table function, we can just pass the education field column alone. Now, for each of the unique category, we have the frequency as well. For example, number of employees under human resources are 27, and number of employees under life sciences are around 606. Likewise, we have frequency of each of the category. By just looking at the numbers, we can say most of the employees are under life sciences and medical. We can use sort function and pass the output from table command to just look at the output in a descending order. By default, the output will be ascending. In order to make it in a descending order, pass a parameter decreasing equal to true. So, as I mentioned earlier, life sciences has most number of employees and followed by medical, and very few people under other and human resource category. Let us look at the output in the form of simple bar chart. In order to do this, you can use bar plot command and pass the output sort a table of HR $education field, and we can pass decreasing equal to true to get a descending sorting. So, we can have the same output in the form of simple bar chart. Here a quick tip. So, if you feel that there are few fields are missing because of a very long text, and also you want to increase or decrease the width and height of the chart, you can go to this quotes setting and say fig dot width and try to play around with different width and height, and run this particular chunk again. We can see now the width of the chart is increased and we are able to see all the labels without any cut. So, here the x axis is different categories in the education field column, and y axis tells for each of the category what is the number of employees or what is the frequency of that particular category. A quick tip here: if the categories doesn't have any natural order like our education field, we can sort the bars in descending order so that we can quickly identify the most common categories. After sorting, it will be very easy to interpret. On the other hand, if you have categories which have natural order like age group, month of the year, day of the year, try to preserve the order of the categories while plotting. Basically, the thumb rule is sort the bars if the categories are of type nominal. Try to avoid sorting if they are of type ordinal or interval. To know more about what is nominal, ordinal or interval, read the Wikipedia article on level of measurements. After sorting, we can try to understand the distribution of each category. We can see that the second most category, which is medical, is slightly lesser than the first most category, which is life sciences. So, the difference is less here, whereas there is a huge difference between the frequency of the third category, which is marketing, and the second category, which is medical. So, the difference that you see is high here. The decrease in frequency of the subsequent categories is very gradual. So, you see a very less difference between the bars post marketing category. We can plot a simple line chart for the same output using plot command and pass on the same values. And make the type of the chart as line chart. To do this, just pass the parameter type equal to L. Ideally, we shouldn't represent the data like this, but this method is used to help you to understand the distribution of categories even better. We can see that there is a deep slope between the second category and the third category, and the slope is not that deep going for the subsequent categories. So, this is just for our understanding. Ideally, this particular output should be represented using a bar chart like this. Finally, we can try to understand the percentage of each category, which is quite similar to Pareto analysis. For this, we need to identify the percentage of each category in terms of their frequency. To do this, we just have to divide the frequency of each category by total number of values in the education field column. So, let us try this in R. So, we first get the frequency of each category using table function. and divide this by total number of rows that we have in education field category. And multiply this with 100 to get the percentage values. So, we can see that life sciences contribute close to 41 percentage of the frequency, followed by medical, which is contributing around 31 percentage of the frequency. Likewise, for each category we have percentage of frequencies. So, this can be better visualized using a chart called Pareto chart, which can be installed via the package called QCC. So, you can just do install.packages and give QCC as a attribute. Under QCC library, we have a useful chart called Pareto chart, for to which we just have to pass the output from the table command. It generates a very useful plot called Pareto chart. So, here on the x axis we have the different categories of education field. On the left hand side of the y axis we have the absolute frequency. On the right hand side we have the percentage of the frequencies. So, we can see life sciences is having close to 600 employees, whereas the percentage is around 30 percentage, and that is what the numbers that we just saw. Likewise, for medical we have around 500 and the percentage is close to 26 or 27. Along with this, we also have a line chart which represents the cumulative percentage. For example, life sciences alone has contributed to 33 percentage, life sciences plus medical is contributing around 75 percentage of the frequency. Likewise, we can just keep adding each category and see how much of the percentage has increased. This is a cumulative percentage graph in the form of line chart. So, in a single chart we have multiple information. On the left we have the absolute frequency, on the right we have the percentage of the frequencies, and inside this we have a bar chart as well as line chart. We can make this chart look even better with a proper title. To do this, just include the parameter main equal to Pareto analysis while plotting this function. Likewise, we can repeat this analysis for any other columns that we have. For example, we have columns like department. So, you can see research and development department alone contributes to more than 60 percentage of the employees. When it comes to education, the education level 3 alone contributes close to 37 percentage approximately. Likewise, for every categorical column we can identify what is the frequency of each category and what is the percentage towards the overall frequency. And it is good to see what percentage of categories contribute to 80 percentage of the frequency. So, here just two categories like life sciences and medical contribute close to 75 percentage of the frequency. So, this is good to understand, and this is what Pareto analysis also tells. In most of the situations there are chances that 20 percentage of the categories can contribute to 80 percentage of the frequency in that particular column. If that is the case, it is good to report and it is a good insight for our analysis as well. So, given any categorical column, try to identify the following. First, we can check out which is the most common categories in a column. In this particular example at least, life sciences is the most common category. And the second question, what is the distribution of categories? So we have this distribution, like life sciences and medical have more number of employees, and followed by that marketing, technical degree and human resources have less number of employees. The third question, separate vital few from trivial many. So we have just two categories which is contributing close to 75% of the employees. So if I want to classify, I can just take the first two categories and put them into one group and rest four categories into another group. Thus we have separated the vital few from trivial many. So given any categorical column, try to do frequency analysis using Pareto chart. Thank you.